Problem number 1, which of the following sets of data has a median of 17.5? Remember, the median just represents the middle number. And you can go about doing this question in one of two ways. Either A, you can enter in all 4 data sets into lists on your calculator and have your calculator find the median. Or what I think is probably better, because it'll take less time, is, for example, look at letter A. If you put the numbers in order from smallest to largest, you have 10, 14, 16, 17.5, and 27.5. And then to find the median, you cross off the lowest and the highest. And then you cross off the next lowest, the next highest. Here, since you have an odd number of numbers, the median is just going to be the middle number. If you had an even number of numbers, you would have to average out the 2 middle numbers. But for letter A, here the median is 16. You could have entered all that data into your calculator, but I think that's too time consuming. Look at letter B. If I put this data set in order, 10.5, 11.5, 12.5, 17.5, and 26. Cross off the lowest and the highest, cross off the next lowest and the next highest, which means here the median turns out to be 12.5. So that's not 17.5, so we'll cross off this data set. Think if you eventually get to letter D, from lowest to highest, 14.5, 16, 17.5, 19.5, and 24. And if I cross off the lowest and the highest, the next lowest, the next highest, the middle number, the number that's left, is 17.5. So I think here, answer choice D is your answer. Problem 2, the number of hours Nadia spent painting each day during a 1-week period is shown below. What is the mean number of hours spent per day? This would be a question where I think you should enter your data into a list on your calculator and have your calculator find the mean. So here, just remember how we do this. We press the Stat button on the calculator and we just press Enter for edit. You enter your data into a list on your calculator. Biggest thing is making sure you enter the data correctly into your list. Then you go back to the Stat button and choose Calculate. And option 1 is 1 variable stats. Make sure the list that you're using matches the list of your data. And here the average, the X bar, turns out to be 2.5. Problem 3, the mean of 4 numbers is 70. When a 5th number is included, the mean of the 5 numbers is 80. What is the 5th number? Well, here we're going to use a formula. In order to find the mean, in order to find the average, what you do is you take the sum of the numbers and you divide by the number of numbers. That's the formula. So if you have 5 numbers, you would add them up and divide by 5. Well, here they're telling you the mean of 4 numbers is 70. So what I'm going to do is I'm going to plug in the mean is 70. The sum is what I'm going to try to solve for. And here the number of numbers, well, they say the mean of 4 numbers. So here I know 70 is going to be equal to the sum divided by 4. So here if I multiply both sides by 4, here I know the sum of the 4 numbers is 4 times 70, or 280. So the sum of the 4 numbers. And now the question says, when a 5th number is included, the mean of the 5 numbers is 80. Well, if I say, okay, the mean is equal to the sum divided by the number of numbers, here they say the mean increases to 80. So I'll plug in the mean is 80. I'm going to try to figure out what the sum is, and now the number of numbers I'm told is 5. So here I'm going to have 80 equals the sum divided by 5. So if I multiply both sides by 5, I know that the sum is equal to 5 times 80, or 400. So I know the sum of the 5 numbers is 400. So I know if I add up the first 4 numbers, I get 280. When I add the 5th number, the sum jumps up to 400, which means here that 5th number has to be 120, because that'll make the sum go from 280 up to 400. So this is a convenient formula that you want to know when you deal with average questions. The mean is equal to the sum divided by the number of numbers. Problem number 4, the chart below shows the frequency distribution of scores on an American history quiz. And here the question is asking you for what is the median score. So a score of 0, the frequency is 1. So one student scored a 0. For a score of 1, the frequency is 2. So two students scored a 1. I want to know what the median is, what the middle score is. And to do this, I'm just going to simply use my calculator. What I'm going to do is I'm going to enter my data into 2 different lists on the calculator. I'm going to enter the score into list 1 and the frequencies into list 2. So I have the data in list L1, and I have the frequencies in list 2. And now what I'm going to do is I'm going to use the frequency list feature of my calculator. I'm going to go to Stat and Calculate and One Variable Statistics. Here the key when you do these questions is, in whichever list you have your data, that has to be the list 1 of your calculator. And whichever list you have your frequencies, that has to be entered under the frequency list feature. Remember, the way you access your lists is you press the second button and then numbers 1 through 6. So here I went second and 1 to get list 1 for the list. Here I did second and number 2 to get list 2 for the list. And now I'm going to go to calculate. And here it turns out that the median is going to be letter D, or 4. So this is the frequency list feature of the calculator. Problem 5, at a horseback riding competition in the Olympics, each rider receives a score from 2 judges. The final score for each rider is the average or the mean of the 2 judges' score. Maddie was one of the riders. If one judge awarded Maddie a score of 87 and Maddie's final score was 84.5, what score did the other judge award Maddie? Well, here I'm going to use that same formula from before. And I know the average, or the mean, is equal to the sum divided by the number of numbers. Well, here it says Maddie's final score was 84.5. How do they get the final score? They find the mean. So here I'm going to plug in the average was 84.5. The question's saying, what score did the other judge award Maddie? Well, for the sum, I know one judge gave her an 87. So if I take 87 and I add the other judge's score, which I'll call X, if I take the sum and divide by the number of numbers. Well, in this case, there's 2 judges, so I'm going to take 87 plus X and divide it by 2. So here I know the average is 84.5. Here I know the sum is the first judge's score of 87, and then I'll call the second judge's score X, And now I'm going to divide by the number of numbers, and since there's 2 judges, I'm going to divide by 2. So here I'm going to solve this thing by using math. I'm going to multiply both sides by 2 to get rid of the fraction. So here I'm going to have 2 times 84.5, or 169. That equals 87 plus x. And here when I divide both sides by 87, it turns out that the other judge gave Maddie a score of 82. So the average equals the sum divided by the number of numbers. For problem 6, a wheat penny is a United States penny that has a picture of wheat on one side. These pennies were only produced from 1909 through 1958. The members of a coin collecting group counted the number of wheat pennies in each of their collections. And below, this is what we call in statistics a line plot. So that basically means that the number of wheat pennies, 20, one particular member of the group had 20 pennies. Here there's no x's over 21, so no one in the group had 21 pennies. Here there are 2 x's over the 22, so that means 2 members of the group each had 22 pennies. So here what we have to do is we have to find the mode, the mean, and the median. These are in statistics what we call the measures of central tendency. And what we're going to do is we're going to again use our calculator, and we're going to use the frequency list feature of the calculator. In one list, I'm going to enter the data, which in this case is the number of pennies. So I'm going to enter the data into list 1, and then I'm going to count up the x's, count up the frequencies. And the frequencies I'm going to put in list 2. So here's what my calculator looks like. In list 1, I have the data. So I entered in the numbers 20 all the way through 40. So you only see up to 30 here, but it continues. And then in list 2, I have the frequencies. So I put 1 for 20. I put a 0 for 21. I put a 2 for 22. And I continue this throughout. Now, did I have to enter in 21 and then the frequency is 0? No, I could have typed in 20 and then the frequency was 1, and then skipped 21 and went 22, the frequency is 2. You could omit the data values that have no frequencies, but I tended to type them all in. And then here, for example, no one had 28 pennies. So I did this from 20 to 40. The data is in list 1, the frequencies are in list 2. And now I'm going to have my calculator find the mean and the median. So here we have the mean, 29.1. The median is 30. And the advantage of using a line plot is that the mode, the most often occurring data value, is pretty easy to see. Here, there are more x's over 31 than any other number. So here our mode is going to be 31. Problem 7. Amy, Darlene, Percy, and Sinclair went bowling. Their scores for 4 games are shown in the table below. In letter A, we have to find the range of Amy's scores for the 4 games. Well, here, Amy's scores are in the first row. The range is always equal to the maximum value minus the minimum value. So here, the maximum value is 170. Here, the minimum value is 130. So here, Amy's range is going to be 40. To find the answers to B and C, I'm going to use my calculator. who had the greatest median score, who had the greatest mean score for the 4 games. So what I'm going to do is I'm going to enter each girl's scores into a list in my calculator. Now you have to be careful when you do this. If you enter your data as it appears in the table, you're not going to be calculating each girl's scores. For example, the way your calculator works is you have to enter the data in columns. So if you enter in the first column from the table, you're not finding any girl's particular data. You're instead finding game 1's data. So notice what my list 1 looks like. Here I have the numbers 165, 140, 170, 130. So I took Amy's scores and I set them up in the first column. Here I took Darlene's scores, the 120, 140, 125, and 140. I put that into list 2. Percy's scores I put in list 3. And Sinclair's scores I put in list 4. And here you're looking at my list 1 data. So here are Amy's data values. And in a moment I'll put up on the screen the 3 other girls' data. Take a moment and try to do this yourself. So in order to answer this question, you just have to be able to keep yourself organized. For letter B, who had the greatest median score? So it looks like here we have Amy is 152 for the median, Darlene 132, Percy 145, and Sinclair 150. So it looks like the greatest median is going to be Amy, who had a 152.5. Who had the greatest mean in letter C? Well, Amy was 151.25, Darlene 131.25, Percy 141.25. It looks like Sinclair, she had the highest mean score of 153.5. So a lot of times these statistics questions will have you just staying organized with large amounts of data. Problem 4. After Darlene bowled 2 more games, her mean score for all 6 games was 135. What could her scores for each of these 2 games have been? So here we're going to be looking at Darlene's scores. And it said Darlene bowled 2 more games. Well, if we go back to Darlene's information, we know that the mean is equal to the sum divided by the number of numbers. So we know from before her mean was 131.25. We know she bowled 4 games, so the number of numbers was 4. So if we want to try to solve that equation for the sum, I'm going to multiply both sides of that equation by 4. So here I know that Darlene's old sum is 4 times 131.25, or if we're really good with our calculator, we know the second value down, this summation x, stands for the sum. So either way, here our sum is going to be 525. Now the question said she bowled 2 more games, and now her mean score for all 6 was 135. So I know the sum of her first 4 games was 525, but now she bowled 2 more games, so now the number of numbers is going to be 6, and here the question said her average, her mean, was 135. So what I could do is again use that formula. I know the mean is equal to the sum divided by the number of numbers. Here the question said her mean after bowling 2 more games, went up to 135. So here I'm going to try to figure out the sum now of her 6 games. So here to get her new sum, her first 4 games, her sum was 525. Here, if I take this equation and multiply both sides by 6, here her new sum is going to be 6 times 135, or 810. So her sum went from 525 to now 810. So the question said, what could her scores for each of those 2 new games have been? Well, we basically know her new sum is 810. Her old sum is 525, which means the difference. So these 2 more games, if I do that subtraction, was 285. So the question said, what could those 2 games have been? Basically, the best way to answer the question is just basically say her 2 more games had to have a sum of 285. So you just pick two numbers. If she bowled a 100th and she bowled a 185, that means her sum would have been 285. So here the answer is any 2 numbers whose sum is 285.